a new process to the test here. All right, it says find the area of the region bounded by the graph of f of x equals x cubed and the x-axis between 0 and 1. I'm sorry, between 0 and 2 for general n. All right, so you think about the process, and it's all detailed on the previous page, but it does boil down to figuring out where your delta x is, b minus a over n. All right, they're telling us that the a value is 0, the b value is 2, so 2 minus 0 over n is the general value of n, so we're going to leave this as 2 over n. All right, so what we need is, if you think about the structure of it, it's the summation. Well, we're going to essentially, or ultimately, I should say, need the limit as n approaches infinity of the summation as I equals 0 to n of f of a plus I delta x times delta x. All right, so let's take this a little bit at a time here. A plus I delta x. Well, the a is 0 plus I delta x is 2 over n. So it's 2I over n. Now if I want f of that, then since f of x, and I'll just make a little note here, f of x is equal to x cubed, I'm essentially, I guess that's my favorite word, I guess. I'm taking the x plus, the a plus I delta x and cubing it. All right, so the a plus I delta x is 2I over n. We're going to take that and cube it. So it's 8I cubed over n cubed. All right. Then we need to multiply that by delta x. All right, so f of a plus I delta x times delta x is going to be this whole shabiggity bangity boomity bombity boomity boom multiplied by this, if I can get it to work. It froze on me. I was too ambitious. Okay, there we go. So 8I cubed, pardon. 16I cubed over n to the 4th, because fun fact of the day, 8 times 2 is 16. All right. Making that look a little nicer. So now I need the sum from I equals 1 to n of this. Now we learned previously a couple of things. One, we have rules for summations, and we're only focusing really on this piece right now. One of those rules is that anything that's irrelevant to the sum doesn't need to be in there. All right, so what I can do is I can take out the 16 and the n to the 4th. So I'm looking at the limit as n approaches infinity. Now the 16s are relevant to the limit also. I mean, it doesn't have an n in it. I can take it out of the whole thing if I want. I think that might be a little premature, so I'll just take it out of the sum. The n to the 4th has to stay within the limit because it has an n in it. 16 over n to the 4th. Then we have our summation, I equals 1 to n of I cubed. Now I want to do, or what I want to do, is make a substitution, and so that's going to be n squared times n plus 1 squared over 4. All right, just a few pages ago in the packet. All So all this other stuff is going to stay put. But now we have the summation gone. That's great news. Do a little bit of housekeeping here. N squared goes into n to the fourth n squared times. 4 goes into 16 4 times. We can distribute. So this is going to be equal to the limit as n approaches infinity of 4 over n squared times n squared plus 2n plus 1, which in turn gives us a limit as n approaches infinity of 4n squared plus 8n plus 4 over n squared. Now, there are all sorts of limit rules, but one of them, hopefully, that you remember is the n behavior model concept, horizontal asymptote concept, but you could also use your calculators if you want. The idea here is, though, that you're going to end up with just a clean 4 out of this, because if you like the horizontal asymptote rules, powers are the same, so we take the ratio of the leading coefficients. The 4 over 1 gives you a 4. All right. If you don't like that technique, that's fine. I got something else for you. Take your original function. We're going to use x's instead of n's. Oops, that kind of moved on me. Plus 8x plus 4 over x squared. You can go into the table and just kind of see how things are shaken out as you increase your value of x. It's kind of hard to tell, though, especially since it's going to fraction form, but you get an idea that it appears to be a 4-to-1 ratio. You see a little north of 8, a little north of 2, numerator, denominator. But you can also look at the graph, so I'll just do a quick zoom 6. You can see it does appear to be leveling off. Where is it leveling off? It does appear to be 1, 2, 3, 4 units up, or at least close to it. All right. But if you're really in doubt, what you do is go into second window, make your table start, or really anything, but make your delta table something really big. Just make it like 1,000. Then go back in to your table. Now you can see it's going by thousands, and you can see that the y value is really truly starting to show that it's leveling off around 4. All right, and now you have reason to believe that it's going to be a horizontal asymptote of 4. Though one caution is that, you probably want to put this back the way it was. So second window, 0, 1, put it back to the way it was before you finish the problem and move on to the next one, so that you don't confuse yourself later on. All right. So that's that example. Now, number 5 is kind of an interesting one. It says area under the graph over the interval. You might want to have a look at the picture and see what you're up against, because we could often make use of symmetry and transformations to help us out. All right, so 1 minus x squared, I'm going to do a quick zoom 6. You can see here it says, again, over the interval of -1 to 1, so that's here to here. So it's just this little arc. All right, so let me bring it in a little bit. So I'm going to go to Window, -1 to 1. The y-intercept of this graph is also 1, so I really only need to go up to 1, so 0 to 1. So we're looking at this figure. All right, so that's what we're looking to try to find the area underneath. All right, one thing I get from this idea is that I don't really have to go from -1 to 1. What we can do is go from 0 to 1 and double the result. The reason why is, just kind of reflect back on number 4. This wasn't that bad, but can you imagine how much more complicated it would have been to cube this expression if this were a binomial, binomial as in like that a value not being equal to 0, probably a lot more complicated. So we want to stay away from that. If we can guarantee that our a value is equal to 0, then that's going to put us in a good spot. All right. So my delta x, so I'm treating this as if it's a new problem. B minus a, this is my a, this is my b. So 1 minus 0 over n, so just 1 over n. Rather than 2 over n, right? Because 1 minus negative 1 would have given it 2. So this is already a good thing. All right, a plus I delta x, so 0 plus I times 1 over n, so I over n. All right. Now, the f of part, f of a plus I delta x. Now, you got to remember that the f of x, now they said y equals, but f of x is really 1 minus x squared. All right, so it's 1 minus I over n squared. So that's the same as 1 minus I squared over n squared. Now ultimately we have to multiply this by delta x, so it's in our best interest to get a common denominator here. So let's make this n squared over n squared minus I squared over n squared. So n squared minus I squared over n squared. All right, so then we're going to take that f of a plus I delta x, multiply it by delta x. So we're taking this expression and multiplying it by this expression. And that's going to give us really this, but with a power of 3 on the bottom instead of power of 2. So that's good. Not too bad. So now I have to apply my summation stuff to that. Alright, so I'm going to get a little cute here and just grab this. I don't want to have to write it every time. Right? Again, anything irrelevant to the summation can come out. So we're looking at really this as being a necessary part of the summation, but the 1 over n cubed, that would really be a coefficient. Quote unquote coefficient. All right. Now, something else that we learned previously or reviewed is that when you have the sum or a summation that contains a sum or a difference, we can split that up. All right. So we're looking at really this. Try to get cute with that. Minus the sum of I squared. All right. So now, it's a little uglier, but very doable. Because that first summation doesn't have an I in it. That's great. So there's a lot of copying and pasting. Right, so it's really, in this case, it's just a matter of kind of switching the order a little bit. Because I'm just factoring that n squared out. But the other piece, that's actually a rule. Oops, I wanted to delete, not copy. So this piece right here, I can actually replace with an n times n plus 1 times 2n plus 1 over 6. So we're getting there. It's kind of moving down on me. So we're getting there. All right. So the sum from I equals 1 to n of 1 is just an n by rule. So I can take this and continue it on. All right, so this is really going to become an n cubed. So now what I want to do is just clean it up as much as possible. Well, I can run through with an n cubed. So if I do that, I'm going to get over n cubed over n cubed. I'm still going to have my limit along for the ride. Alright, so this part at least is going to cancel to a 1. The top, I have to distribute that out. I don't have a choice. So I'll just take care of the binomial parts of it first. So limit as n approaches infinity of 1 minus, so this part is going to be n squared, 2n squared. The outers are going to give you an n plus 2n is going to give you 3n plus a 1, but the whole thing is negated and multiplied by negative, multiplied by n. But you know what, I could just bring the negative down here. I kind of already did anyway. But I'll run through with the n. So 2n cubed plus 3n squared plus n over 6n cubed. So now, because our exponents are the same, we're in a pretty good spot here. All right. But one of the rules of limits tells us that if we have a sum or difference, or a product or a quotient, you can take the limit separately. So limit as n approaches infinity of 1 minus the limit as n approaches infinity of all of this. So in this case, we're looking at 1, limit of a constant is a constant, minus 2 over 6. 2 over 6 is 1/3, so 1 minus 1/3 is 2/3. However, that's only half of this parabola, or bounded region. So that's only going from the y-axis to the right endpoint. So just this region here. I want the other side, so I got to double it. So our final answer should be almost wrote 4/5, 4/3.